Okay, so let's look at variable types. In Java, there are about 8 data types. These are probably more, but 8 primitive data types. And the word primitive just means very simple data types. Okay, so I'm going to go right into the IDE here, and we're going to go open a creative project in here. So if you want to do together, that's fine too. You can just listen and watch, that's okay. So I'm going to create a new folder in here. Instead of chapter 1, I'm going to create a new project of type Java project. Okay, we'll just call this chapter 2, or you can call it unit 2, however you want it, that's fine. And then just go ahead and click finish. So expand your folder here and write it in the src here. We're going to create a package. I'm going to get, show you how to use 2 packages. Again, packages are just a way of how you can organize your file. So let's create a new package. Right click on it and just new package, or the icon up here, the orange square package icon. And we'll call this just data types.java1. Okay, and you don't have to check this box that says create package info. You can just uncheck that one. Again, package names can be anything you want. Okay, it's just a series of folders, and they are used to bundle your projects in a single area. So later on, you'll see that we'll got to add a lot of classes in a single project. So when a single project is, it's a very specific project to, or a program to run or do something, right? So or any type of apps, and you can have a lot of packages in here, and you can organize your files based on that particular package. So go ahead and create a class. We'll create this class. We'll just call it data types or data type, right? Usually class names, again, by convention, is always singular, and how they are named. You'll see that some people use plural, which is completely fine. There's no rules for that, but just by convention, it's always singular. And then go ahead and submit, check this box, the static void main, because this is the main program. It will start from here, and just click finish, and here we are. I'm going to remove this comment tab here. Again, in IDE, in Eclipse, if you want to zoom, I think just press the Control plus and minus. Okay, you zoom in, zoom out. There are other shortcut keys too. You can even customize them if you want, but by default it has some built-in shortcuts, and I'll show you a few of them as we start coding. So data types. Okay, this will be the primitive data types. Okay, and there are 8 of them. And we'll explore each of them, and we'll look at their types and how do you use it in the program, and why and when you should use them. Okay, other languages might have more or might have less. So if you are familiar with database, they have a lot of data types, more than your usual programming languages. Some languages may have very little, or maybe like almost none at all. If like, for example, if HTML is a language, then usually that's like almost like there's no data type in there. So the 8 primitive data types. Again, primitive means it's just very simple, and a term that is also very common is called a constant. Okay, so we have a literal constant. Just like math, you think about literal constant, it's just a number or a character of some sort, right? It's the actual character or the actual number itself. For example, if it's say 8, that's a literal constant. It's not only a literal constant, it's a type of constant called integer, right? So it's a numeric constant. So this is some terms in here, and we'll deal with the numeric type first. So we have the literal constants, and then we have a numeric It's a numeric type, and it's also unnamed. Okay? Unnamed means there's no name for those. So once you use it in the code, and you only use it once, and that's it, because constants can be changed, right? You only use it one time. So for example, if you want to do something like system out, like sys out, so SOUT, and then again control spacebar will give you that function to print. If you print the number 8, that is a literal constant. It's a numeric unnamed literal constant. And the 8 can only be used once. You cannot change its value, right? So if you go and print that out, you only see 8 on the console. And if you press play, you see that is exactly what's being displayed in the console down here in a second. So there it is, right? That's what you see. And so numeric literals or numbers, you can only use it on the right side of your assignment operator. So for example, you cannot just suddenly say 8 is equal to 2, right? You can't do that, or 8 is equal to whatever, right? So you can't do that. Same thing with your constant for characters. We'll see in a minute. So all these are constants. To duplicate this line, if you put your cursor right what the line is, and then I think you press the mine may not work. Mine was kind of weird last time. We'll see if it works this time. See if it works in yours. If you press the Control Alt and then press the up or down arrow key, see, mine doesn't work. It flips my screen completely upside down. Okay, so which is really weird. I think on your screen, if you do it, you actually duplicate the line. Okay, if it works. If it doesn't, well, maybe kind of like mine. But usually, if you do a Control Alt and you press the down arrow key, it will duplicate this line for you, and so you don't have to type it. So that's a numeric number. The other one is a string literal. We have a string literal. It will be like, it's just like this. We've done this before, right? This is a string literal. It's just the actual string that cannot be changed. You cannot reuse it, right? Once you specify that, print that out, then that's all it is. That's a string. And then we have a character literal. Same thing. Just a character. You have to wrap a character, a single character, by a single quotes only. Okay, you can only hold one single character, either a to Z or a special character like a plus or minus. Doesn't matter. Any of those characters, even numbers, can also be counted as characters. Again, only one character can be placed inside a single quote. If you put two of them, it's no longer a character. That's a string. So that would violate the rule. Okay, so you have those these three types of literal constants. You have the numeric, string, and character literals. Okay, let's talk about variables. Variables are, again, these are just placeholders, right? That points, let's say, placeholders point to a memory address in RAM. That's all they are. It's like a bucket of some sort that will store some type of data. The word variable is very general in term. The actual name of a variable is called the identifier, right? Identifier, just like an ID. Actual name of a variable. Okay, and you see that in math all the time. You know, let x equal to some number, or let function f of x equal to something. So all those are called identifiers because they're unique, right? And so identifiers are very unique. So let's look at some of these primitive data types, and I'm going to comment these out. I'm done with these, so I'm going to just comment them out here. So let's look at the first one. The first type is the integer type, okay, or int. Now, when you declare variables in Java, you would put the data type first, followed by the name of your variable or the identifier. Without the identifier, you cannot, you can't store data, and those data can't be changed. Those will be, again, constants. So we would say something like int. I'm going to put here, just for demo purposes, I'll put in I for int, and we'll put the min number here. So here, int is the data type. Min is just the variable name. This is the identifier. Okay, it's unique, and you cannot have you can never use the name again in the same scope. We'll talk about scope in a bit. So you can assign an integer value to this variable called min. Again, min just a placeholder. And the word variable, as you can see, means it varies, right? It allows us to manipulate their data over time. So you can assign a number in here. For example, if I put 12, then that's an integer, right? Integer are whole numbers. And it has a maximum value and a minimum value based on the size of these numbers. They have a very specific name for those. I should probably go above and do one more above here. We'll go from the smallest to the largest, okay? So the smallest type is called what's called a byte. So again, if I put byte, B for min. Okay, so that's like the byte type. This one here has the size of an 8-bit, if you are familiar with binary numbers, 8-bit signed integer. Integer means whole number, right? So it will take only that much. It's assigned to integers, so we talk about the negative and the positive number as well. So if you put the 8-bit together, if you count the binary, you get what's called a maximum and a minimum value, right? So the max here is, so in the 8-bit, you get 128, okay? So the, including 0, so you get 127. That's the maximum value. And the minimum is the minus of that, which is 128. That's the 8-bit signed for a byte. So if you use a byte, you can only store that much value in there. So if I were to say 123, that's completely valid, right? Because the number 123 is in the positive range, but it's less than 127. If you put 128, you see that it would read out and just say this number is out of range, right? Because a byte only stores up to a maximum of the value would be 127, positive, and negative is 128. So then the reason why is 127 less than 128 is because the 0 is included, was counted as a positive number. Okay, so otherwise we have equal distribution of those numbers. So if you want to use something really, really small, then you will use a byte. It takes less memory, only 8 bits, right? And that's pretty tiny, but you're maxed out at that number. So if you want to use something, let's just say, if you know for sure that your function or your code only use that 50 people in the class or something, then you can use byte, right? That's enough. You wouldn't use a large number. So that's the bit. And to print the minimum number, you could do something like byte dot. You can see that if you type in capital B for byte, that you have a max value. So you can do something like that, and it will give us the minimum value. It will tell us what the minimum value is. And we can do another one here, just say B max, and we do the same thing, max value. Okay, and then we'll print those out in a bit here so you can see what they are. Alright, So let's print them out. Let's say SOUT. I put here byte min. Okay, and then the plus the concatenator, and you just put a variable name in there, which is bmin. Okay, and you can duplicate this line, and then or print it one more time. This is the max value, and then bmax. So if you run it, it will print out the minimum value you can use for byte and the max value you can use for byte. So if you run this now, it should give you those numbers. So here we are, we have a negative 128. That's the minimum, the smallest number you can use that the byte type can contain. Anything smaller than that, the number range will be out of range and you have an error. Okay? So that's the byte type. The next is the integer. Integer is the next. Actually, no. Before that, there's one more before the integer. This is called the short type. Okay. Short type are 16 bits. So as you can see, this number is almost like it doubles every time, right? Again, 16-bit. It's a signed integer. Again, all these are whole numbers, integers, and there are about 4 types in the integer group. It's just that the capacity is much more. So you have 2 to the 16. So here again, we can do the same thing. We can find out the minimum and maximum. So you can say short is the actual data type. Okay, as min is equal to short. As you can see by the word short and byte, the capital S or capital B, it tells us that's a class. So again, by convention, you always capitalize the word for every word in your class name. You can get the min number. And you do the same thing. So we'll copy this, and we'll change it to a max. And we'll get the max value. And I'm going to copy lines 24, 25 right below it. So you can print them out. Let's just say short max, short min, and short max. S and S. Save that. And when you run it, you see that that's the range. Okay, it's from the minus 32. We can say this like 32K, right? 32K to a positive 32K. Okay, and that's the exact value we can use for short. If your number is 1 larger than that, then it will be out of range. Okay, so again, short is, I mean, if you think of something of your calculation that is only going to be used that much character or that much size, then that should be enough. Hello? Okay. Is it still pouring outside? Okay, so we can copy this. You know what? I'm going to copy this. And then just replace this part with the integer, and we will change the integer to, let's set the integer. So this will be like int type, int. Okay, all these primitives are the data types. You can see they are all lowercase. Okay, lower s, lower case with I, lower case with a b, byte, and so on. They're primitive. So as you can see, I already used smin, so it's yelling at me, right? I'll put I here for imin, and then int for imax. And just change this to int, the nt, eger. Okay, one thing about int is that The shortcut for int is int, but the actual class name is called integer. Okay, so with a capital I. Okay, so and then we can print this int out. Find out how big they are. I am max and I am min. These are 32 bits now. Okay, it's double every time, right? So A 16, 32. Next will be, you can guess it, 64, right? So it's 2 to the power of 2 and 3 and 4. So if you print these out, you'll see their max integer. It's about 2 billion, right? So a total of 4. I mean, including both together, it would be like 4 bytes. I mean, 4 megabytes, including negative and positives. So that's the integer. So we can say that this is about 2 megabytes. This is here is equal to 4 megabytes, right? And this is just 1 byte. Integer, the byte will be just 1 byte. So 2 meg, 4 meg, we including negative and positive range. And then one more. It's called the long. The long type will be just LONG. Long are 64 bits. This is quite big. It's the largest integer type. You will probably only use this, wisely, because they do take a lot of memories. As soon as you, initialize or set a variable called like lmin to lmax, it doesn't matter what it is of type long, then it will accumulate that much memory in the computer. So if you have a lot of large data size, they can consume a lot of your data. So again, this will be like 8 megabytes, which is like double every time. It's a 4 by 4. So you put long here, and you see how big they are. It's probably very long. I can't even know how to pronounce that word. And then L and L. Okay, if you run it, let's see, that's pretty big. So there it is, that's long. 9, I don't know, it's a petaseptillion. I'm sure there's a name for that, but it's pretty big. So these are the 4 types of integer types in Java. Okay, they are, again, usually the most common type we use is the int type. It's like right in the middle, right? Not too big, not too small. It's about right. So you see that a lot of the code will use mostly just integer type. Okay. Notice here we only read in the values and then assign those to those variable names. Now, when you put a number, let's just say down here, if I go and type in here long, let's just say num is equal to 1, 2, 3, 4, 5. Okay. Yeah, that's fine. Just do this as well. So long is pretty big, 64 bit. And if you have a number, another one here, we call it of type int. We'll call this one here the, I don't know, num1. I'll rename this. Num1 is, 56, and we'll just call this num2 here, just to make it kind of consistent. Okay, so 1 is integer, 1 is a long. And let's just say we want to add those two numbers and put it to a total of type int. We have total is equal to num1 plus num2. Okay. You see that there's a line there just tell me something. Something is not correct there. And if you mouse over this, it will tell you, it says type mismatch cannot convert from long to int. Because we're adding a large number of a large memory size, I'm going to just put in here so we can see it visually. Let's just say that integer type only stores that much num and size, and the long is this much, right? Okay. So this data size, we add that with this one here, so we get something like a total will be something like that plus that, right? You get the total. I'm just to kind of put into perspective. So I'll put it here. So the total will be something like that, the long plus the int type. And that is the total in memory size. But if you look at this type here, it's a type, the total is an integer type, and integer type only can store this much capacity. So it's impossible to put this whole thing inside that little box. Okay? And that is the reason why it says you cannot convert this large size into a small size container. So this doesn't work. So just be careful when you do this type of expression or calculation. The other way is it's fine. If I were to change this to say long, then it's okay, because all I'm doing is basically, if you look at this, the total here will be fine, because this is not probably, it's probably incorrect here to see it. I'm just saying that this size, the integer is only consumes that much memory, and the long is this much, and so therefore the ultimate result is it's going to be big enough or small enough to fit inside the long type. Okay, so the container is much larger, so you can fit that in there. So notice I don't have to change the data type. I don't have to convert the integer to a long type. So typically you want to, in some cases, or actually in certain cases, you have to convert one type to another type in order for it to work. So usually you'll say, only integers can be added to integers. You cannot mix those numbers. Right? But in this case, it's true because they're all integers, and as long as the total is equal or less than the size of the memory size, then it's fine. So you don't have to convert. Okay? So it makes here, so the longest one's the biggest size. I can add integer. I can add the long. I can add the short and the byte all in here, and it should still fit the long because it's pretty big. Okay? So all those small numbers can fit into the larger one. So those are all your all the integer type. And then we have two more. These are the decimal types. Okay? Or we call these the floating point types. Okay, you might have the term floating points before. So floating point deals with decimal, what we call this in math, real numbers. Right? It has a decimal point. And the reason why it's called floating is because that point can float anywhere between the whole number, right? So you have a lot of decimal places, and when you write that in the scientific notation, you see that it's e minus or plus that point. And you can drag the number of the dot in any position, and that's why they call it the floating point. Okay? Whereas the whole numbers don't have floating point. So this one has two types. One is called float, So the float here, I should probably just put a note in here. Float. Okay, this is a 32-bit floating point type. Okay. So if it's a float, again, you can go fmin is equal to float.min value. So we can see what that is. And we can do the same with the float fmax. Floats.max value. Okay. And I'm going to just copy these two lines so print them out. This will be float. And then float fmin, fmax. Okay, so if you print them out, you see how big they are. And it's probably too big that you will probably see the scientific expression or notation. And then just zoom that out just a bit. So the long, and then the minimum will be like, the smallest will be, as you can see, 1.4 to the minus 45 decimal places to the left. If you move that 45 decimal places, that's the smallest number. And if you move 38 places from here, including these, digits, so it should be about the same number of decimal places to the right. That's the maximum size. Okay, that's how big and how small a float contains. And then finally, the next one here, we're going to copy this whole lines here. We'll put here. This is the double. And doubles are the largest float number in Java. And other languages, some might have different, but I have more. Like Visual Basic, you have float, a double, you have a decimal as well. But this will be the double type. Double will be 64. And this is one of those very common number as well, even though it takes a lot of memory, you'll usually use a lot of double in your code, even though float will still be fine. So we put dmin, dmax, and then here again just double, and we'll print this dmin, dmax out, and we'll see how large they are. And of course, the reason why you have those large numbers, why do you need them, is because of precisions, right? When you do math, especially scientific research stuff, you do something to the 300 decimal places or even 1,000 decimal places. To that precision is when you use double. It's very, really precise. When that 100th or 400th position number is a difference, then that is when you use it for. Otherwise, a float will be enough. This is also very important, especially if you write a program for, let's say, stock exchange, right? Those numbers are very important. One little digit can make a huge difference when you deal with billions of dollars. So that's the maximum and minimum for the double type. As you can see, is 324 decimal places, left or right. Okay, so and that's the largest number you can go in Java.
Now it's like overtype one, or just like if you type something, it doesn't like add in between.
Did you fix it?
Yeah.
Okay. Okay. All right. So all these are the numeric data types. There are 6 of them, right? We have the short, the byte, the short, int, long. These are all decimal. Whole numbers. And then we have 2 decimal types, float and double. Okay, these are all primitive types. When we say primitive, it's kind of hard to understand until we get to chapter 3 and 4 later on. We talk about reference type. Those will be different. I'll show you a little bit what that means, but for now, those are the number of types. Let's deal with the other 2. two more. These are non-numeric. This is a Boolean type. Boolean is the smallest data type in Java and pretty much in any language, because it only deals with zeros or ones. Okay, this is the true or false, only true or false. There's no other values, and it doesn't take 0 and 1s, even though in the program itself it's a 1 bit. I should say here 1 bit. A binary, right? Zeros or 1 only. So there's no other values. Either it's true or false, on or off, okay, active or inactive. And so it's called a Boolean type. And then, you can't do much other than just say set something to true or false. And when you do that, you say something like Boolean found is equal to true or false. Okay, and you have to use the keyword true or false in lowercase, not uppercase. And you cannot put 0 or 1s. It doesn't match. So if you put that, it will be invalid. Okay, and some languages allows you to use true or false or 0 or 1s, but not Java. And then so that's it for that one. Very simple like that. Boolean and then true or false. And then the other one is the character. Okay, this is a character, and you wrap your characters with a single code. I did that already, right? It's a single character only. This is a 16-bit data size or type, right? Or in other words, we call this what, 1 byte, right? Was it 2 bytes? Or 1 byte? Yeah, 1 byte. So one single character takes 1 byte. So here we have like just char is the actual data type for char, and again, if you put something like state, would be like, well, not state. That's 2 characters. Let's be like, for example, maybe like gender, right? Let's say M for male, something like that. Right, it's 1 single character, and that's how you would assign that. Okay, so these are the 8 primitive data types. And then let's see if I miss anything here. You'll see that sometimes in the book or elsewhere you might see something like this. I meant to show up here, but I kind of missed that. I'm going to say something like, if I declare a variable of type long, okay, if I say number, I put again 1, 2, 3, 4, 5. Remember that long is the largest integer number data type you can use. Okay, if you don't specify, if you just do this, because it's long, it stores a number and has a whole number here. You can't put zeros in here, right? It's not a decimal. So by convention in Java, if you want to force that number 1, 2, 3, 4, 5 to be of type long, then you have to append here the very last location here, the letter L, to make that into a long type. If you don't, then it will treat that as an integer type. Okay? Even though you assign that to a type of long, if you don't, I mean, this is just how Java is built. If you want to force the number to be really big of the long type, then you will put the L here so to make this number as a long type. Otherwise, it'll be defaulted to an integer type. it will treat that as an integer value. By the same token, and you do your float. If I say float is equal to, float, let's just say price, right? If I put 12.45. Okay, you see that it has an underscore there. Even though float is a decimal number, it should be legal, but it has an error because we mouse over this. It says type cannot convert from double to float. Okay, so if you don't put a value here, a character after this, it will think that number 12.45 is a double type, and the double is much larger than a float, so therefore it doesn't fit into the float memory space. Okay, if you want to use that as a float, then again you want to force that by using the F, put the F at the end of the number to force that constant number to be a float type. Okay, by default is a double type. So as you can see, if I go down here, put double cost, if I put 12.99, there's no error because the default is a double type. Okay, so you'll see that in the code sometime. You might wonder what that is. Either uppercase F or lowercase f is completely fine. Same thing here. I prefer to use the uppercase L because 1 and L lowercase looks very identical, so it's confusing. So put that L there if you are using long. And this is also one of the reasons why a lot of people don't use long, because of that nature. Okay. So then with the float here. So with the float, you have to always put that in here, otherwise it won't work. And again, that's the reason why they use double instead. So double, you don't have to worry about that. Okay. Both can be lower uppercase. Yeah, it's just that if I put L here, you'll see that almost like a 1. You almost can't tell. So just use uppercase. It's just easier to distinguish. But it could be upper or lowercase. Okay. So here is a double and 12.99. Again, by default is a double. And if you want to use this as a float, it will still be fine, even though I have a double type. But I'll put a float over here because float is much smaller. It will fit into a double, so that's fine. Okay. Not only that, you'll see that it should also take in integers, right? Because integers, any of those long or long, it doesn't really matter because they all can fit into the double. The double is pretty big. And double and long are both 64 bits, right? So they are the same size. And that's completely fine.